Hi, welcome to today's webinar. Today we are live from Citrix Synergy here in Los Angeles. Thank you for everybody from Europe staying up late. You're probably gonna stay up a bit later as well to join the Geek Speak live afterwards. Today, once more, we are joined by Andrew Morgan and David Coombes, and today we're going to see what Andrew had cooked up in his labs recently. So, Andrew?
Hi everybody, I just wanted to echo what Tron said. Very appreciative of you taking your time to come over, particularly for the Europeans, because it must be very late at home. Today I'm joined by a good friend of mine, Dave Coombes, who I've been dealing with quite a bit from project to project, and we want to show you what we've cooked up and what we're trying to do here around, negating IOPS and looking at what's happening on your back-end storage. And I think you're gonna like what we've had in mind. So without further ado, I'm gonna crack on if that's okay. So the Virtual Desktop I/O Challenge. Look, IOPS are something that you can't talk to a customer about virtual desktops for more than 5 minutes without having to tackle this challenge. It's boring, it's challenging, it's big, and it's expensive. There are many ways to negate this with clever inline storage. There's hypervisor level RAM caching. There's all kinds of products out there, but the through a kind of little bit of a thought journey and a little bit of playing and testing, we've come up with our own little solution. I hope you see what benefit we come out of it, and then of course there's local resources as well. I mean, quite a lot of VDI environments are hoping to leverage local resources like SSD or whatever else to try to take the pain away from the central storage idea. So that's an option too. So I mean, what can you do? I mean, realistically speaking, you can spend crazy money on hardware. You can spend crazy money on software, or you can go with the whole software-defined SAN, with that both Atlantis and VMware and and other key competitors are competing in. But what you're realistically doing then is you're adding a software license to expensive hardware that you also have to add on. So it's a challenge at the best of times. So sorry, Tron is currently adjusting the screen and interrupting my train of thought. So moving on. This whole idea came from a blog post about 2 years ago, where a bunch of us kind of community Citrix guys were sitting around a table at E2E VC in Vienna, I believe. And the Geek Speak for E2E was all about storage, and the mood in the room wasn't great because everybody is sick of talking about this. Vendors are throwing all kinds of solutions at you, hard and fast from every direction, and there's the choice out there is wide. What the methodology we came up with around this was, we decided, hey, you know what, RAM is cheap. What can we do to aid that? So we came up with an idea to do kind of a in-VM RAM cache using Microsoft Extended Write Filter, or EWF. And what we did is we abstracted that EWF from the Windows embedded standard Think Client version and had a look to see what we could do with it, and the results spoke for themselves absolutely and thoroughly. And then taking it a step further as well, we added it to Citrix IntelliCache, because obviously our cache was focusing on writes, and IntelliCache was focusing on reads. So it was a natural kind of parity. So a blog series was born around us that where we walked through each of the steps one by one and had a look at what exactly you could do with currently available solutions to you as a bit of a play. And we proved it worked. We absolutely proved it worked, and without taking too much credit, Citrix echoed what we'd done. They provided a RAM cache in PVS with spillover to disk, negating the fear of RAM caching in the previous products, but also allowing you to cache but spill over. Now, the Citrix solution isn't perfect. There are a lot of additional things that we're going to be talking about in our product and how we do it. But it was a good first step for Citrix, because A, they acknowledged what the community was saying, and B, they implemented something that, although required a hotfix, was really, really good. So we tried to do it ourselves. So this is kind of where the conversations gets a little funny, because my colleague here, Dave, was actually beta testing ThinKiosk 4.0, which you guys all know at this point. And throughout the process, Dave was a great kind of a great beta tester and giving me lots of feedback, teaching me how to program a lot of the time. And we got talking about this blog post series, and Dave just kind of chirped up, I think I might be able to do something about that. Since the last year and a half, we've been working away intrinsically on how to put this together. And Dave had kind of already stepped through this process already. So I'm gonna hand over to Dave now and kind of tell you what he had done previously and how we brought it forward from there.
Yeah, thanks, Andrew. Yeah, it's a complete coincidence, I guess, really. I guess it was several years back, was the times when RAM disks were all the big craze, and even focusing sort of physical XenApp world where people would use a RAM disk and move particular files onto that RAM disk. But that was always a problem because, preloading that RAM disk, how do you get, you can't store the stateful information that was on that RAM disk. So I was looking at ways of having inline cache. Nothing to do with IOPS saving at the time or anything like that. It was just a way to use the power of RAM, but have it inline and still allow it to have a persistent storage on an actual physical disk. And as Andy said, so I'm doing the work with ThinKiosk, pointing me towards his blog post, and it's like, yeah, I think this same technology could be used to solve this problem as well. And as you'll hopefully see very, very soon, we believe we have.
Oh, absolutely. I mean, we're extremely excited about this because it's, from my point of view, it was extremely rare to find somebody who understands the video market as well as Dave does, and also a kernel developer. So, I was doing backflips when I realized there was an opportunity here to actually move this forward, because although I had tried it previously with somebody else, it just kind of didn't go anywhere. And, Dave has absolutely stepped up to the mark on this one and delivered something that's really, really cool. So anyway, that's enough about us. I'm going to talk about what ThinIO is and how ThinIO works. So ThinIO, you install it into the VM. So it's an inline, in-memory optimization system. And the way to look at it is, as Windows requests an IOP, it traverses through ThinIO. Now this is running as a system-level filter driver, so it's extremely fast. You can allocate the size of the cache you wish to use. Nice and small for VDI, or nice and big for remote desktop services or XenApp hosted. And any read and write that goes through the cache is immediately stored. So if one block is read and then subsequently requested again, it doesn't go back down to the disk. It comes straight back up again. Now, I'm not going to bore you with read caching because everybody has a solution. Microsoft has CSV, XenServer has IntelliCache, and I believe there's a product in there for Hyper-V or vSphere as well, based on CBRC, but I'm not how supported that is. So, where it really shines is on the writes, because, as a write comes down to the disk, we're returning to Windows directly, immediately, that the write has been committed to cache, and then any subsequent reads or writes to that blocks also go to that cache. So, as your reads and writes come down, and the more that becomes cached, and we'll talk about this a little later, the IOP reduction is absolutely monstrous. We were seeing 80% IOP reductions on stateless virtual desktops and even terminal services environments. We're seeing 0 write IOPs, 0, unless we absolutely have to. And the key thing about the ThinIO filter driver is, if it absolutely does need to page over, it'll do so in a very controlled manner. So as you're the guys from Atlantis and all the other storage vendors will tell you about the crimes of boot storms and the difficulty of the kind of waning and flexing IOP environment, where during the morning you get a big spike in IOPs as everybody logs in, and you get a big spike at lunchtime as everybody's on Facebook and Google and committing loads of stuff to disk, and then of course on log off as well, the profile's committed and you get a big spike in IOPs as well. And what that really hampers customers from doing is generating this baseline they require for when they're sizing their SAN. I mean, they need to size for the absolute worst case scenario in order to make sure things are performant all the way through. And what ThinIO does is it absolutely standardizes this all the way through. You don't need to plan for the worst case scenario, because ThinIO sucks up so much of these IOPs during login and during log off that your SAN can pretty much stay relatively the way it is. So realistically speaking, and one or two comparisons we've actually done with the customers who are beta testing, is it turns a desktop workload into a much more reliable server workload. So and in that scenario we mentioned earlier on about the cache being of a certain size, we don't need to cache absolutely every single write. We can look at how frequently the block has been used and when it was last accessed, and then from that point on make the intelligent decision to commit it to disk because we know it's taking up space in RAM, or to maintain it. And even if we do commit it, we still get optimization on read because it's still in the cache. It works for both hosted, shared, and pooled desktop workloads. So immediately, with no complications. We can go in there on cloud platforms, we can go in there on VDI in a box, we can go in there on VMware Horizon Fuse and desktop. Basically, if it's a Windows operating system, ThinIO works. And of course it can spill over in a cache flood scenario. So if the user does something completely out of the ordinary, the system is still performant because it's really only writing out enough space in order to tackle that write. So you're dropping back down to disk speeds at that point. But up until then, you've been running in RAM speeds. So it works really, really well. So walking over some of the benefits of ThinIO that we've seen from our testing, in limited numbers, it's accelerating and mitigating, both read and write IOPS. So what that means is your user gets a much better experience for relatively cheap, because RAM is cheap. It's become a relatively cheap commodity at this point. And then if you look at local storage as well, because you're only sending through IOPS that you absolutely have to, your SSDs are going to last infinitely longer too, because the RAM is taking care of most of that buffering coming in and out. It provides that small, reliable I/O pattern that we spoke about. It dynamically changes its own cache data to deliver the best user experience. So it has that intelligence baked in to tell you whether, to at least deliver you the best solution with what's available to it. It can be installed in any environment with relatively ease. The benefits, and the key thing is the benefits can be immediately seen, because you don't have to change any of your infrastructure, any of your hypervisors, anything like that. You literally install this, and on the next reboot, you're seeing at least a 50% IOP reduction. And it's desirably priced on machine basis as opposed to the industry as a whole. So by that I mean, you don't have to go out and order a massive piece of tin you need to put into place and change your delivery methods to put it in. You don't need to buy something that sits at a hypervisor level with any kind of stringent requirements around what LUN you present or what hypervisor you're running on. And we don't particularly have to worry about any kind of hypervisor patching too, because we're absolutely agnostic. And then taking it a step further as well, the other solutions, if you were going with desktop as a service, if you wanted to accelerate that desktop, but you don't have control of that underlying delivery platform, this product just sits straight into the operating system and goes from there. There's additional benefits too about sitting inside of the VM, because a lot of products go with on a hypervisor level, and while that approach is fine, we really do feel that there are benefits to doing in VM too, because you get direct visibility of what that operating system is doing and interacting with the storage. So we can see what Windows is doing, which A, really helps us negate IOPS, and B, helps you identify particular IOP patterns from what you were doing. With the GUI, you can tell exactly what is happening from an IOP perspective to and from that disk without having to rely on the buggy Windows counters. It's near 100% compatibility with all current virtual desktop products out there. You don't have to change your model, as I mentioned, and you can preempt boot I/O, and that's something I'm going to talk about just a little later in the presentation. This is where the being in VM actually really shines. It's dramatically cheaper and less risky than running as a platform as a whole, because if you've got something sitting underneath your virtual desktops on a host and it has a problem, well, then you've lost that host. If you've got a problem in VM, well, then that's in VM. Rapid deployment, it's a 20 meg download. It takes less than 30 seconds to install, and after reboot you're ready to go, and it works on cloud services out of box. So to give you an idea of how ThinIO kind of presents itself and how it works, what we're looking at here is we're looking at a VM remotely or locally, and immediately you get an exact view of what exactly is happening in ThinIO. So in the top left here in this box, we're seeing how many IOPS we saved. Now those figures are from an IO meter, so that's not going to realistically represent. And look, we operate a no FUD policy that was an IO meter, but I'll show you exactly how it looks in a minute. So on the left there, we can see exactly how many IOPS we saved, and on the right we can see how many we sent through. As you hover over these graphs, it'll give you exact and real-time figures, and it auto refreshes itself every 5 seconds. On the top right, we see how much cache we're currently in use. Volatile would be writes, optimized would be read blocks ready, and then the free would be the amount of cache we haven't already committed. Now ThinIO tries to fill its own cache with optimized reads as quickly as possible, because that's where we're beneficial. It's only when we become volatile over a certain percent do we start to look at what parts of the cache should we get rid of. On the bottom left, you see how many IOPS were requested in both read and write, so you can see what your workload is. So you can see if it's write heavy or it's read heavy, and then on the right hand side you see the actual. So in that scenario, there were a number of million write IOPS that were sent down, but actually we only served up the writes, and you see that by hovering over. And then on the bottom right as well, we're giving you a percentage as well, of a percentage how much the cache has served back, and a percentage of how much that came from disk. Very, very easy, very, very easy to pick up and go. And in the top right hand side, there's a number of options you can use there to enable, disable, or get additional information from the driver. There's also a real time statistics button there that gives you a graph, so you can while you're doing your testing to size your IOPS, you can see exactly what's coming through that machine, give and take. So in blue, you're going to see the requested IOPS from Windows, and green, you're going to see the actual IOPS we had to pass down below. So in a virtual desktop scenario, your writes should be absolutely covered. Your reads will get better the more the user does within the session, and there's intelligence there to keep an eye on that. We're not going to say we're never going to send out a read, and I think maybe that graph would be slightly misleading. We do have to go down for reads at times because it may not be in the cache, but once we've got it in the cache, it's ready and going. So this isn't a no IOPS scenario. This is a absolutely optimized, cutting the IOPS right down to what is required. And of course, the statistics are actually a great way of demoing exactly how this can be delivered and exactly what you're using going forward. So I mentioned being in VM has benefit in the sense that we can see what Windows is doing, and during our testing, we actually realized Windows is horrible at boot time and optimizing itself in the sense that as the services start up, they're requesting the same files over and over again. It's too early for the Windows caching mechanism to actually kick in, and it's requesting blocks from all over the disk in a non-contiguous manner, as you'd expect it to do. What we realized was, because we have a map of what blocks and what parts of the disk are required, as because our cache is aware of that, why don't we tackle this bootstorm issue while we're at it here? Because your average server will request about 80,000 IOPS on boot, give or take. I mean, if it's a particularly busy XenApp server, 80,000. If it's a quieter one, it could be 50,000. But that's still a lot of IOPS on boot. By us, having a cache file there, we elected to pause Windows, categorize those IOPS and put them in a contiguous manner and read them all off the disk before they're required. And by doing that, we're absolutely mitigating the IOPS and that random consistency that Windows does across the disk. We're loading everything in a contiguous manner as quickly as possible, and then as the additional services start up, everything's already in the cache. Which, taking it a step further, so in Windows Server 2008 or 2, the first user who logs on is always going to have a slightly slower application launch time because the Windows caching mechanism kicks in. But in a VDI scenario, you have that issue all the time, because you don't get the benefit of having one person opening the application and then everybody else takes advantage of the caching. So by doing this read-ahead technology, you can choose to optimize the base core set of applications as well. So not only are we reducing the boot time I/O, we're also reducing dramatically the launch time of the core applications inside of that desktop. And this can be completely configured to what you want to do. It's just a matter of logging into your image when it's in golden image state, opening everything you require, and then committing the cache file. Easy as that. And the cache file, I should point out, is the largest one we've ever seen was on meg, and that was on a particularly busy machine. So 1 megabyte of file versus a 60 to 70% reduction of IOPS on boot is an absolute good trade-off. So I kind of walked you through this already, but to give you kind of like a graphical representation of what happens, before and after ThinIO, I got my glorious assistant, my sister, my graphics designer, to kind of throw together a little animation of how this works. So what we have here is, on boot, the Windows is requesting blocks all over the place, repeatedly the same blocks, and it's not in an optimized or contiguous fashion, giving you this massive amount of I/O on boot. With ThinIO in line and using the pausing system, it does this read ahead, sorts everything in a contiguous manner, goes around the disk, and then resumes Windows. So it will make its way around the disk in a contiguous manner, having everything available in the cache, and then from there, Windows is resumed to allow you to boot. And we've seen, upwards of 40 to 50% reduction in boot time, not only reducing just IOPS. So you're speeding up the boot time, and you're taking a lot of pressure off your disk subsystem. So just let me go back to this presentation. So the proof is in the figures, really. What we're looking at here is, on the left hand side, we've got a terminal server or remote desktop server with just a RAM caching enabled. straight away we saved. This is a machine that was booted and the first user logged in. Straight away we're seeing that we saved in and around the 40% mark IOPS in the top left here, and we're seeing that our cache was in and around the 40% utilized for reads. Of course, writes were very small on boot because there's not a whole heap happening on boot with write. So although we did make a good saving there of nearly 50%, it could be so much better. And on the right here, you see a machine that was pre-configured for read ahead. So taking these figures here and moving them over a bit, you see that this has gone from a relatively a smaller percentage than average to a massive reduction. So you can see that in and around the 30,000 IOPS were requested on boot. We only sent through 5,000. So I mean, my maths are failing me at the moment, but even in the cache requirement here, you've reduced the amount of access to disk on reads to 20%. So it's absolutely huge. And as I mentioned, the boot times are infinitely faster because we're doing it this way. And it's so simple to do. Like, you literally just install ThinIO, set the cache size to what's recommended, and then log into the golden image and pre-create the core applications that are going to be required by that user. So I'm going to throw caution to the wind here, and we're going to do a quick demo of ThinIO because every vendor will throw IO meter at you. It's not a good test because some vendors will insist on a 20 gig IO meter. I mean, how often does a user touch 20 gigs across that disk? Some vendors will claim 7 million IOPS off a single hardware device. You got to bear in mind that our test environment here is it's actually server to 2012. We had a slight lab issue, so we moved over to another one. Server 2012, 24 gig of RAM, and we're using a 6 gig cache. And we performed the read ahead in advance of this demo. So moving over to our RDP connection. Here we have a ThinIO agent open. We've already ran IO meter once here, so that's why the figures are so high. And we have the real-time graph here in the background as well. So what we're going to see now is we're going to run an IO meter, and we're going to show you the results. So as you can see there, pushing through to a particularly bad SAN or a lab environment there, we're pushing 78,000 IOPS through a Windows RAM cache. It scales and scales and scales, and even in a flood scenario, you can see from the real time graphs back here, we are absolutely chewing through IOPS through this cache. And if you were to look at the real time statistics over here, we've got relatively very little going on from a disk point of view. I mean, the send through has gotten so small at this point that it's not even visible. That is our wee little demo, and as I mentioned, I don't really like IO meter from a demo point of view, but it kind of gives you the impact of what this RAM cache can do. If we were to run this RAM cache or this IO meter without ThinIO online, you'd be looking, if you were lucky, at 2,500 IOPS. So the maths are staggering. So that's ThinIO in a nutshell. I'm going to open the floor to questions now in a minute because I'm sure you guys are super curious about what's going on. In 1.0, our testing is targeting stateless machines. We've a little more work to do on stateful. It's coming, and we're tackling 64-bit desktops. 32-bit is coming. But 64-bit allowed us the quickest route to market. And realistically speaking, 32-bit desktops are starting to become a niche as opposed to the majority. So that's why we went with that one. Stateful technologies are coming. We've got some really clever ideas. And because we're in line with the disk, we can tell exactly what I/O is happening. So we can look at what files can be absolutely discarded from even in a persistent scenario, like the page file and that kind of stuff. Straight away tested was XenDesktop, XenApp, VDI in a box, and VMware View. We have a little bit more testing to do on Microsoft ODS, but it absolutely works. We just want to make sure we're comfortable. Licensing. Everybody has licensing. It's unavoidable. I really hate when a vendor will talk to you but won't give you an idea of what they're actually doing. So we're being very upfront about this. It's going to be a per VM license. Remote desktop services will have a slightly higher license price, and there is going to be a community edition available. So you can get 100 mega cache out of ThinIO for free, downloadable, once the product is released. We're opening this in a closed beta. We've had a number of customers testing already. We'd like to do a little more testing before we go wide scale. Consultant and community edition NF4s will be available. So get in touch on Twitter or whatever else, and we'll make sure we hook you up. If you want closed access, or if you can think of a use case where that would fit in here that you'd like to test, if you're currently in the trenches with a customer and IO is kicking your ass, come talk to us. We'll release it to you, and we'll help you build up your use case. Questions. So I'm going to open the floor to questions now, and I'm going to ask my beautiful assistant Trond here to jump in and see what we can help.
So let's see
answer.
here. We saved the question for the last because Andrew is the English version of Sean Bass, so it's impossible to break in. So we have the questions on the screen.
Okay, so well, Rory had an issue with what's been seen on screen, but we'll come back to that one. Okay, so Brian Thornton asked a question there. Being in VM, does this mean that it is installed at the hypervisor level and it can be tested on a VM level? So no, it's inside of your virtual machine. It's not at the hypervisor level. We're looking at some really cool use cases around Hyper-V and cluster shared volumes as well that we're not ready to start talking about yet. But we do have an option for hypervisor there. But for the moment, it's absolutely in the desktop. Do we have any more questions? I know there's a pricing conversation there that's currently being hammered out. Most of the vendors are coming in at in and around the €100 per user mark. We're aiming to be dramatically less than that. It's going to be on a per VM and a concurrency level, so it's not going to cost you an arm or leg. It's going to be extremely cheap. Okay, so to get on to pricing, or to get on to the next questions, what are the thoughts on when it will be out of beta and available? So we're hoping to get this out the door as soon as possible, but we just require a little more help. Now, we're only a startup, we went out to our current ThinKiosk customers and we got some testing done, but we need you guys to kind of get behind this and let us know how you get on. The more we can get behind this, the quicker we're going to be out. Realistically speaking, I'd like to be out the gates in 6 weeks. That would be worst case scenario. Is optimization also visible in a bare metal config XenApp PVS? Okay, so absolutely. We have a little more testing to do on PVS, but in theory, yes. We're only targeting stateful machines at the moment until we get further down the stateful roll. But bare metal, stateless, absolutely, we're going to be targeting that. There's a question around kernel here that I'm going to hand over to David because I see the word kernel and I automatically assume popcorn. So the question is, are there any concerns about stepping on the kernel with how we are optimizing on boot?
I guess the quick answer is no to that question. I say we're not stepping on the kernel at all. All we're doing is taking information off the disk and storing it in cache. So the kernel will request or think it's requested something from the disk, and it has no idea where that's been served from. It just happens to have been served from the cache. So it is none the wiser. So no, there are no concerns there. Absolutely, and just from an I/O control point of view, I mean we're only locking a block we're accessing at that given nanosecond. So it's not like I said it pauses Windows, but Windows can continue until the cache carries on. What we're doing is we're just loading it as quickly as possible to step over. So feel free to go further or expand on that question. You've got, if you want to send either myself or Dave an email on, I'm Andrew at Thinscale Technology, or Dave's David at Thinscale Technology, and we can take that conversation up further if you like. To get back to the questions, time frame for release, I covered that. Has every VM got its own cache? So yes, absolutely, every VM does have its own cache. We're not sitting at the hypervisor level for the reasons we discussed already. While this, there are two approaches, and we do have some plans around Hyper-V, but we'll get there at some point. Are we considering a monthly model for service providers? Absolutely. Absolutely. So we are going to be looking at a chargeable model of concurrency based on your uses. Mark, feel free to get in touch and let's have a chat about that. So Rory asks, are there any virtualization product there? Are there any that remains untested or it doesn't play well with? I haven't come across anything that it doesn't work with. I know that there is going to be a little bit of a challenge with Citrix provisioning services and the
what's called the altitude of a driver. And now I'm nearly sure we're below PVS, but I'm not sure how happy Citrix will be with supporting it until we get this out to gate a little further. So RDS caused me a slight difficulty, but it's there's nothing that's actively causing a problem from a technology point of view. How does the licensing work? It's a trust model. I don't like deploying licensing servers. I really hate deploying licensing servers for a bespoke application. It's the wrong thing to do. Thinscale is a trust model. You pay for what you tell us you're using. Simple as that. And I don't want to take that conversation any further because licensing is a pain in the backside. So cache sizes. Cache sizes are an interesting one. I hate to answer cache sizes with the consultancy response, but it really depends. What you're going to do here is you're going to configure a cache size based on our recommendation, and then you're going to test it to see how applicable that is. In task workers scenarios, 250 to 350 megs of cache, perfect on a desktop layer. And you get economies of scale on RDS there as well. So you could scale that back to 250 quite easily. It really depends on how heavy and how busy your users are. But again, RAM is cheap, and the cost of this product is going to skirt below everybody else. So that's to take a Windows 2000 server or a Windows 2008 or 2 server. So if you were to take that number and multiply it by 250 by the amount of users you have, maybe add an extra 500 just to be on the safe side, you'll reach a nice round number. But it's a suck it and see scenario. Let's see what you need and go from there. Okay, so RAM is, just to answer your question there, Sebastian, RAM isn't sacrificed. It's still available and it's still usable. It's just caching in line, and we do have plans to be able to both expand up and expand down in version 1.2. So you'll be able to use as much as possible while the machine is relatively quiet, and then it'll scale itself down if it starts to run into a scenario where you need more. That's on the roadmap. It's just not quite ready yet. Okay, so just to move on to a couple of more questions. Rory, just to answer your question, do you guys tailor recommendation based on customer environments, and will you just give minimum recommendations? We will absolutely help you with your recommendation and your sizing. The level of information that comes out of this driver. Sorry to skip to live demo mode. God, I hope this doesn't fall. I don't live to regret this, but under the driver details, you'll see what we call the nerdy stats, and in here you're going to get more information than you could possibly imagine around what kind of IO has come in and out. We're taking 1 minute, 5 minute and larger samples. We're looking at how big the block size is that's coming through. We have a ton of counters to watch out for. We give way more information in here, and with this information we can also help you size that out. So that point is covered, so to speak. To go back to the questions. So I think I've covered the cache size question. If you want to know more about that, please do email me. That's something I didn't cover off. If you hit thinscaletechnology.com tonight, my diligent graphics designer is currently publishing the information. You're going to see a big ThinIO link and registration. What's going to happen is you're going to submit a little bit of information about your environment to make sure that you're good to go with our testing, and then we're going to reach out to you and help you with your initial rollout. So VMware charging us for RAM usage. Are you deduping RAM cache? Yes, absolutely. It's on the roadmap. It's not going to be in 1.1, that's for sure. But we are going to look at maybe consolidating blocks. It's going to be something that we're actively going to chase after, but it's just not on the immediate horizon for now. Price will become apparent very, very soon. There's going to be a dramatic discount for people who do enter into the beta program. So documentation, absolutely. We're going to document to the nth degree exactly how this driver works and what you can configure and what you can't configure, and that'll be available once we go to open release. Does this RAM expand pay well with Hyper-V dynamic RAM? Okay, so Hyper-V dynamic memory is going to try to give you the smallest amount of RAM possible and size up depending on what you need. So what ThinIO is going to do, it's going to request its cache size, and it'll be locked in from the start. As we look at expanding and detracting the cache size, obviously that'll play better with dynamic RAM from Hyper-V. But yes, you won't run into a scenario where Hyper-V will accidentally page out your RAM cache. That just won't happen because our driver is holding it. So yeah, to respond on getting the bits, it's currently oh God only knows Tron's I know it's 10 o'clock at home, but it's 5:30 on Tron time. So what time is it?
Oh, here it's 1:30.
1:30. I'd expect the website to be updated in the next 2 hours, and everything will become apparent. Keep an eye on Twitter, and all will be revealed. Do we have any more questions, or are we all satisfied? Well, I think silence is golden. So I just want to really thank you for your time to come along and have a look at what we're up to. I think it's going to be a really exciting couple of days. If you are lucky enough to be at Synergy, we're going to be downstairs. Come see us, come talk to us, have a play with it, try to break it. And we'll go from there. And in a completely unrelated fashion, ThinKiosk 4.1 is going live tomorrow. Website. Oh, sorry. There's my diligent helper, Brendan Kiley. Website is now updated and live. Go have a play. Go register. Will I be documenting the questions and answers? Yes, I'll ask Tron to make sure we pick it out there. To everybody who attended, thank you so much. I'm going to hand over to Tron now to close out, if that's okay. And I really look forward to talking to you guys on Twitter and on email or whatever else the next couple of days. As I said, Andrew at thinscaletechnology.com or David at thinscaletechnology.com. Reach out, talk to us. We love talking about this.
Thank you to the Thinscale team. Thank you, people, for showing up. As always, we're gonna send out a replay link so you can share this with your colleagues that didn't have time to attend. To celebrate the 25th anniversary of Citrix, we're running a 20% discount on the XenApp training course. So if you head over there, you will have a $100 discount this week. Make sure to sign up for the next month's webinar. We're gonna do it with Tom. He's going to do a 50,000 VDI seat implementation, so that's going to be very interesting. And also make sure to stay around. The GeekSpeak is going to start in, couple of hours?
2.5 hours.
2.5 hours. The GeekSpeak Live is going to start, so make sure you get that as well. Thank you, everyone. Bye-bye.